Welcome. This is Dr. Michio Kaku, Professor of Theoretical Physics at the City College and the Graduate Center of the City University of New York. And this is Exploration. Every week on Exploration, we discuss the fascinating world of science and its impact on society. And today, leading off, we're going to summarize some of the top stories in science. Of course, the whole world mourns what happened in Manchester, England, a senseless act of terrorism, cutting down the lives of so many young people. And then we have to ask the question, why? What's happening? Well, we'll say a few things about this tragedy, and also link it to what's happening in outer space. Yes, something is happening in outer space that has sent the astronomical community into a tizzy. It turns out there's a star out there, 1,300 light years from the planet Earth. Something weird, really weird is happening to the star that leads the tabloid newspapers to believe that it's a sign of alien intelligence. Now, normally, scientists would simply roll their eyes into the heavens and say, "God, humbug." Well, not anymore. Astronomers are scratching their heads to explain this anomaly in outer space that some people think might be linked to the existence of an advanced civilization in the heavens. And we'll say a few things about that because the anomaly is heating up even as we speak. And then we're going to say a few things about the brain. Yes, the human brain. We know that the human brain learns to read at a very young age. But what happens when you start to read at age 30? Let's say you are illiterate in India. It turns out that over 39% the population of India are illiterates. What happens to your brain if you start to read at age 30? Well, some surprising results have emerged using brain scans to look at how the brain adapts to new kinds of stimuli, including learning how to read. And also body fat. Can body fat predict cancer? Normally, some people would say, no way that body fat can predict cancer. But no. There's a new study done on 43,000 people over a 12-year period of time showing conclusively, yes, looking at the numbers, that if you are overweight, that definitely increases your chance of getting certain forms of cancer, and we can even put a number to the percent probability of increased incidence in cancer. Well, let's just jump right into some of the top stories of the past week in science. Well, of course, aliens and flying saucers are not considered seriously by the scientific community, but here's one incident that's causing quite a bit of chatter among astronomers who are scratching their heads wondering, what the hell is happening in outer space? It all starts with a star called Tabby's star, a nickname. It is 1,300 light years from the planet Earth. And normally, we expect starlight to drop just a teeny bit, perhaps a fraction of 1%, because a shadow of a planet has moved in front of that star. That's called an eclipse or a transit. A transit when a star moves in front of the mother star so that the main star's light has diminished. Now, let's say Jupiter moves in front of the sun. By how much is starlight decreased? The answer, 1%. So even a gigantic planet like Jupiter moving in front of our sun would only diminish starlight by 1%. Well, get this. In the year 2011, it was a 15% drop that was recorded. That is huge, a 15% drop in starlight. Some people thought, well, maybe it's an anomaly. Maybe it means somebody put dust in the telescope's mirror. Well, the Kepler satellite tuned into that star, and in 2013, 2 years later, starlight dropped 22%, a staggering amount. At that point, you could not neglect it anymore. And in 2015, a paper was published trying to go through all the different kinds of theories to explain a staggering 22% drop in starlight. For example, maybe it was a comet storm, a storm of comets that went in front of the star. Other people said maybe a planet plunged into the star. Other people said maybe the disk of dust surrounding the star interfered with starlight. Well, one by one, all these things were being removed off the list of probable candidates. First of all, if a planet plunges into a star, it's not a periodic event. It only happens once and only once. And here we had two events. Well, of course, in 2015, people were waiting for the next incident, but nothing happened because the Kepler satellite was crippled. So we missed 2015. So once again, in 2011, it dropped 15%. 2013, it dropped 22%. And 2015, well, it wasn't observed because the Kepler satellite was crippled. Now, 2 years later, in 2017, there was a prediction that in May of this year, there would be another sudden drop in starlight. Well, you can imagine the excitement when word went out that, yes, it's happening again. So far, it's only dropped 3%. Other people think that it'll drop even further. But even as we speak, astronomers from around the world with any telescope they can beg, borrow, or steal are turning their sights onto that star, Tabby's star, looking for the dip, which is happening even as we speak. It turns out the cycle time between dips is about 750 days, and right on schedule. 2017, May of this year, there is a dip taking place even as we speak. And so it means that even the established media is now being aware of this. The Washington Post, of all newspapers, the Washington Post even had a headline talking about the weirdest star in the heavens. Now, if one by one we begin to rule out what could be causing that dip, then the last candidate on that sheet of paper is aliens from outer space. But even then, it must be a very advanced alien to cause a drop in starlight of 22% when even Jupiter could only create a drop of about 1%. So among science fiction buffs and among astronomers, the leading candidate is a Dyson sphere from a Type 2 civilization. Wow. First of all, what is a Dyson sphere? And second, what is a Type 2 civilization? And how does that link in with terrorism? Well, first of all, let's describe what a Dyson sphere is. Many physicists expect that as an advanced civilization tries to harvest energy, sooner or later they're going to have to mine the sun. The way you get starlight from the sun is to create a sphere, a gigantic sphere that surrounds the entire sun, or a series of satellites called the Dyson swarm that orbit around the sun, harvesting the tremendous starlight that comes from the sun. So that's a Dyson sphere or a Dyson swarm. Then the question is, what kind of civilization can possibly create an object that big that it could envelop 22% of the surface area of a star? And that's a Type 2 civilization. So let me explain what that is. Around 1964, a Russian astronomer, Nikolai Kardashev, was sick and tired of talking about aliens from outer space without quantifying these things. He was a physicist, and physicists like to quantify everything. We like to give numbers to things. So he created a scale of Type 0, Type 1, Type 2, Type 3 civilizations. A Type 1 civilization consumes the energy output of a planet, an entire planet's worth of energy, meaning that they can harvest every single drop of sunlight that hits that planet's surface. Now, of course, on the planet Earth, we only harvest a fraction of the starlight that hits the planet Earth. So we're not even on this scale. So a Type 1 civilization is truly planetary. And we can imagine for the moment that they're capable of doing things like controlling the weather, or perhaps controlling the course of volcanoes. They are so powerful, they control planetary energy. And then we go to a Type 2 civilization. A Type 2 civilization has exhausted the power of a planet, and they now begin to harvest the power of the sun itself by creating a sphere a sphere around the mother sun that absorbs all the starlight from the sun. Or they might create a Dyson swarm that is a swarm of satellites that orbit the mother star, harvesting much of the energy from that sun. That's type 2. Type 3 civilization exhausts the power of a planet, star, and what's left. What's left is the galaxy. And so a type 3 civilization is galactic. It harvests the energy from billions of stars. And if you were to compare these civilizations to science fiction, a type 1 civilization would be similar to something like Buck Rogers or Flash Gordon. You would hop into your private rocket, zoom anywhere you want to on the planet Earth, and begin to interfere with the Earth's weather, its atmosphere, volcanoes, earthquakes, because you control planetary energy. Then there's type 2. A type 2 civilization is like Star Trek. That's right, the Federation of Planets has colonized a tiny fraction of the galaxy called the Alpha Sector. And a type 2 civilization can play with stars. Then there's type 3, a galactic civilization like the Empire of The Empire Strikes Back, where you harvest the energy of billions of stars. Now, if you get out your slide rule or a calculator, you can calculate that the ratio between a type 2 and a type 1 is about 10 billion. So a type 2 civilization has 10 billion times more energy than type 1, and a type 3 civilization has 10 billion times more energy than a type 2 civilization. Well, on this scale, the scale of advanced civilizations, what are we? Are we type 1 that can alter the weather? Are we type 2 that can play with stars? Are we type 3 that can roam the galactic space lanes like in the movie Star Wars? No. We are type 0. We don't even rate on this scale. And where do we get our energy from? Do we get our energy from the galaxy, from stars? No. We get our energy from dead plants, oil, and coal. But we can, on a calculator, calculate when we might attain type 1, type 2, or type 3 status. Well, Carl Sagan did a mathematical calculation years ago, and he figured that we are actually not quite type 0. We're type 0.7. So we're well on our way to becoming a type 1 civilization. So what are we? We are type 7, getting our energy from oil and coal. But we are roughly 100 or 200 years away from being type 1, planetary. And we can see evidence of this everywhere we go on the planet Earth. What language will this future type 1 civilization speak? More than likely, they will speak English. How do I know that? Well, go on the web and find out what are the most popular languages on the web. The number 1 language on the web is English. Number 2 is Mandarin Chinese. Also, we're seeing the beginning of a type 1 sports. Take a look at the Olympics. Take a look at soccer. We're seeing the beginning of a type 1 sports. We're also seeing the beginning of a type 1 music. Just look at rock and roll, rap, and youth culture. We're seeing the beginning of a type 1 planetary youth culture. We're also seeing the beginning of a type 1 economy. Take a look at NAFTA, the European Union. Take a look at all the big, large trading blocks that are emerging, because the economy is going planetary as well. Not to mention the fact that even high fashion is going planetary. Anywhere you go on the planet Earth, once you visit the high-end area, you realize they have the same luxury goods, Chanel and Louis Vuitton and Tiffany's, the same high-end stores at all the places you go to on the planet Earth. Now, some people say, well, maybe this is not a good thing because local cultures will be obliterated when a planetary culture of type 1 culture is created. Well, that's actually not quite true. Everywhere you go on the planet Earth, if you meet the elites on that country, then you're talking about people that are bicultural. They, of course, know the local culture, the local language, but they also know one European language and a little bit of Western culture. That's anywhere on the planet Earth once you visit their elite. Now, in the future, we're not going to be just bilingual, we're going to be bicultural. That is, everywhere on the planet Earth, people will have their own local culture. They'll know their own local songs, dances, and folklore. But in addition to that, they're going to be planetary as well in terms of culture. Especially the elites, they'll be bicultural. They'll be fluent in the Chanels and rock and rolls and rap musics of the planetary civilization. So cultures are not going to disappear as we go planetary. In fact, they'll be preserved forever on the web. Now, what does this have to do with terrorism? Well, a Type 1 civilization is prosperous. It's scientific. It is multicultural. It is planetary. Now, some people don't like that. Some people say, well, why do we want to be in a multicultural, planetary, scientific civilization when they prefer to be in a fundamentalist, sectarian civilization that is unscientific? And that's where terrorism comes into the picture. You see, a terrorist cannot articulate what I just laid out. However, in their gut, they don't like the way the world is headed. The world is headed toward being more scientific, not religious, to being more secular, not religious, not more fundamentalist. And as a consequence, these people feel out of place. In other words, we're seeing the beginning of perhaps the greatest transition in the history of modern civilization, the transition from Type 0 to Type 1. Congratulations. You are alive to see the beginnings of the greatest transition in the history of modern civilization. Transition from a Type 0, fragmented, sectarian civilization to a Type 1 planetary civilization. But it's not guaranteed. In fact, the transition between Type 0 and Type 1 is perhaps the most dangerous of all the transitions, because we still have all the sectarian, all the religious, all the racial hatreds of a Type 0 civilization with us, even as we reach for being a Type 1 civilization. Now, Elon Musk, the man behind SpaceX and Tesla Motors, was once asked the question, do you believe that there are aliens out there? And he said, yes, he does. Then the next question was, well, how come they don't visit us? And his answer was, well, maybe, just maybe, they killed themselves. Maybe they committed suicide. And that's a problem that all civilizations must face, you think, as they rise from the swamp, that, yeah, sometimes all the ravages of the past, all the ideologies and all the craziness of the past are going to haunt them. And maybe that's why they don't visit us, because they committed suicide. And so what I'm trying to tell you is something very simple. We are embarking upon the greatest transition in the history of modern civilization, from being a fragmented, sectarian, fundamentalist society to becoming planetary, that is, scientific, that is, prosperous, that is, less secular than in the past. But the transition is not guaranteed by any means. And the terrorists, of course, feel uncomfortable being in the 22nd century, when we will become a Type 1 civilization. They feel more comfortable being in the 10th century. They feel more comfortable being in the past, when things were unscientific, when religion was the dominant role. In fact, fundamentalist religion was the dominant feature of human society back then. And so I think that's one of the takeaways we can take, that yes, terrorists are uncomfortable, not just with people's religion, but the way civilization itself is going. But I firmly believe that, yes, we are on our way to becoming Type 1. Now, by the time you are Type 2, by the way, you become immortal. Nothing known to science can destroy a Type 2 civilization. Now, a Type 1 civilization is quite vulnerable. Vulnerable to nuclear proliferation, to designer germs, to a greenhouse effect. But by the time you're Type 2, you are immortal. Comets, asteroids can be deflected. You control the weather, so you don't have to worry about global warming. And even if the sun dies, you can leave your solar system, either in rockets or by moving your planet, because your civilization is that advanced. And so by the time you are Type 2, you are immortal. Now, some scientists that I've talked to say that, well, all this is interesting, but they're never going to reach us. Civilizations in outer space cannot reach the planet Earth. There's no such thing as flying saucers or UFOs, for the simple reason that they are too far away. But you see, that assumes that they're just type 1. That is, maybe 100 years away from us. But let's say that these civilizations are thousands of years ahead of us, millions of years ahead of us, because, of course, those time frames are nothing but the blink of an eye compared to the universe, which is over 13 billion years old. So I don't buy it when even a scientist says that aliens can't visit us because the distance between stars is so great. Well, that assumes that the aliens are maybe just 100 years more advanced than us. But in reality, if they are thousands of years ahead of us, perhaps they are type 3. And by the time they are type 3, new forms of energy and new forms of physics are available to them. By the time they reach type 3, they can access what is called the Planck energy. The Planck energy, some people think, is the greatest energy limit in the universe. It is the energy of the Big Bang. It is the energy of a black hole. It is the energy by which you can begin to rip the fabric of space and time itself. In other words, drill a hole. Drill a hole, take a shortcut through space and time called a wormhole. Now, of course, today, we don't have any evidence of a wormhole. We can't create a wormhole because it takes too much energy. But by the time you're type 3, there's a possibility that you can literally drill a hole through space and time and zip across the universe, just like what they do in Star Trek. And again, that's probably for a type 3 civilization. A type 3 civilization would be maybe 100,000 to 1 million years more advanced than us. But if you get a sheet of paper, do the numbers, you can see that a type 3 civilization might actually have the energy to play with the fabric of space and time itself. Well, okay, moving on, let's say a few things about the brain. We know that the brain is a learning machine. It literally rewires itself every time it learns something. But reading is a skill that is not imprinted in our brain because reading is relatively new on an evolutionary scale. Therefore, when you look at the human brain and you look at the centers of the brain that light up when you begin to read, you realize that the brain cannibalizes other parts of the brain that are evolutionarily geared toward other tasks, reroutes the circuits so you begin to read. Well, scientists did an experiment. They went to India, where the illiteracy rate is 39%. They went to a very poor village, recruited women in that village that were illiterate in their 30s, and they taught them how to read. Well, after 6 months, they did a brain scan to see what the differences were, and they were rather pleased with the results. As expected, what they found was that the brain hijacked other parts of the brain, specifically the brainstem and the thalamus, rerouted the circuits so that ancient part of the brains could adjust to a modern invention called reading. And so it shows how plastic the brain is. The brain can definitely learn new tasks by essentially cannibalizing other parts of the brain, which shows you that the brain is a learning machine, constantly rerouting itself every time it learns a new task. Also concerning health, can body fat predict cancer? Well, normally you might say no. I mean, after all, what's the difference between being overweight and coming down with cancer? Well, here's a new study done on 43,000 people over a 12-year period of time. Perhaps the most authoritative look at this question, and they found, bingo, there was a link. It turns out that if you add 11 centimeters to your waistline, your risk of getting an obesity-related cancer increases by 13%. Let's say you add 8 centimeters to your hips. And what does that correspond to? That corresponds to an increased risk in bowel cancer by 15%. So then the question is why? Why is it that if you get obese, then the number of cancers that you get increase. Well, they think it's due to several mechanisms. First of all, being overweight causes an increase in the production of sex hormones like testosterone and estrogen, and they in turn accelerate the growth of cancers. You can show that when a person has hormone therapy, that the rate of cancer increases and tumors accelerate as a consequence. Also, excess body fat increases the level of insulin in the body and also the amount of inflammation. In fact, the conclusion of this study, this massive study done on 43,000 people for 10 years, the conclusion of the study was that being overweight is the biggest single contribution to cancer except smoking. Smoking was the most prevalent cause of cancer. For cancers that can be avoided by changing of your lifestyle, the second was being overweight. So a word to the rise. Your mother probably said it to you. Stop smoking, reduce your weight, exercise, have a better diet, and if you want to delay the onset of Alzheimer's, you should increase your circle of friends and use your mind and perhaps learn a second language. The lesson here is that your brain is not frozen in time. It's not carved in stone. It is plastic. It is malleable. It literally rearranges itself, unlike a computer, because your brain is actually not a computer. The brain has no programming. It has no CPU. It has no Pentium chip. It has no subroutines. You can remove half the brain and the brain still functions. You remove one transistor from a computer and the whole thing crashes. Our brain is a learning machine. It's not an adding machine at all. And you can take advantage of this fact by learning new skills, by changing your lifestyle, by absorbing information and digesting it, by creating a larger circle of friends and a larger circle of activities. That's the way to keep healthy. That's the way to have a better outlook on life. And that's the way, actually, that we were designed to handle our living in a new environment. Well, I'm afraid that's it for the first part of exploration. Welcome. This is Dr. Michio Kaku, Professor of Theoretical Physics at the City College and the Graduate Center of the City University of New York, and this is the second half of Exploration. In the first half of Exploration, we summarized some of the top stories of the past week, including the strangest story in memory from outer space. Have astronomers detected a machine from an advanced civilization circling a star 1,300 light years from the planet Earth? Well, astronomers are in disagreement on that question. In the second half of Exploration, we're going to talk about another controversial aspect of technology, and that is fusion power. People often ask the question, when are we going to have the power of the sun in a bottle? When are we going to have unlimited energy from seawater? When will we have the power of the stars in our living room? Well, that's the promise of fusion power, that one day the oceans will give us seawater, which can be separated, and hydrogen extracted out, and the hydrogen heated to millions of degrees and fusing into helium gas plus enormous amounts of energy. In fact, that is the secret of the stars. The stars burn hydrogen fuel to release fusion power, in the process creating helium gas, which is actually commercially viable. However, the joke is every 20 years, we physicists promise that you'll have fusion in 20 more years. 20 years later, we make the same promise, saying that, well, wait another 20 years. Well, are we any closer to getting fusion in a bottle? With us today is Professor Charles Seif of New York University, author of the book, Fusion in a Bottle. And we'll ask that question, when are we going to have unlimited power almost for free. Professor Seif, you're a journalist. However, you've written about cosmology, and now you've written a new book called Sun in a Bottle, The Strange History of Fusion and the Science of Wishful Thinking. So how did you, as a journalist, get interested in things that most journalists avoid like the plague?
Well, I have to say I'm really a physics geek at heart. Back before I became a journalist, I studied physics and mathematics, and it was only fairly late in my education that I decided that I was more suited to writing than I was to actually performing scientific work. Mm-hmm. So even at the very beginning of my career, I was interested in writing about physics because that's what I loved. And so my career has been covering physics for a decade and change. And from the very beginning of the time that I was writing, among my first pieces was a large piece about fusion. And coming from the physics point of view, I thought of this wonderful thing which would solve the world's energy crises. And as a journalist approaching it, I saw that it was a little bit more complex than I had initially expected with my physics goggles on.
Okay, well, let's just jump right into your book. Your book starts out at some of the hairiest days of the Cold War. In 1945, the United States drops a fission bomb on Hiroshima and another fission bomb on Nagasaki based on uranium and plutonium. But then in the 1950s, a new race emerges, not with uranium and plutonium, but with the hydrogen bomb. So explain to us, what is the difference between the fission bombs that were dropped on Japan and the hydrogen bomb based on fusion?
Well, fission and fusion are two sides of the same coin. In some sense, every atom wants to be iron. It has iron envy. So things which are heavier than iron, like uranium and plutonium, want to split apart in the same sense that a ball wants to roll down a hill. And in the process of splitting apart, they release energy. Fusion, on the other hand, takes light elements. Light elements, in some sense, want to stick together and get heavier, getting closer to iron. It turns out that the fusion end of the reaction is more energetic per atom than fission. That is, breaking apart atoms gives you a lot of energy, but fusion, sticking them together, gives you a lot more. So at the end of the Manhattan Project, when the project ended, the United States had a bomb that used fission to power it. In its simplest form, basically all it did was take two hunks of uranium, stick them together, and wham, you get an explosion. So it was easy to do once you got the uranium material to set off the reaction. Edward Teller, a physicist at the Manhattan Project, was very strongly in favor of using the other side of the coin, fusion, because he realized that it would lead to a weapon of unlimited power, and he called it the super. And the idea basically was to use an explosion, a fission explosion, to set off a fusion explosion, which was much greater. And Teller was right. The weapon that he eventually created was vastly more powerful than even what obliterated Hiroshima and Nagasaki. To give you a sense of scale, Hiroshima was about a 14-kiloton explosion, the equivalent of 14,000 tons of TNT exploding in the same place at the same time. The first full fusion test, called Ivy Mike, was 10 megatons, 10 million tons, almost 1,000 times larger than Hiroshima. It evaporated the island it was on. And that was just the beginning. In theory, you can make a fusion bomb as large as you want. The biggest ever detonated was the Russian Tsar Bomba, which was more than 50 megatons of TNT. And after a certain point, it's pointless to get larger because you just wind up lifting a larger and larger column of atmosphere into space, so it doesn't do that much more damage. So even though it promised unlimited power, unless you wanted to destroy the Earth, it wasn't that much more effective at doing damage than a fission bomb. But at the same time, the Cold War was getting hot, The Russians had detonated their first nuclear weapon way before Americans thought they could get it, thanks in part to a spy operation that penetrated Los Alamos. So a panicked America realized, well, we have to get ahead of the Russians and keep nuclear supremacy. So they turned to Edward Teller's idea of a super bomb as a way of staying ahead of the Russian nuclear weapon industry. And as we know, the Russians caught up very, very quickly, and it turned into a nuclear stalemate where each side had so many weapons in their arsenal that they could destroy the world many times over.
And I should also point out that when I was in high school, Edward Teller was actually my advisor, and he actually sort of guided my career in the early years when I was at Harvard. However, moving on now, we have the Cold War in full swing, and people are now used to the idea that there is a bomb 1,000 times more powerful than the Hiroshima and Nagasaki bomb. But other people have said, well, look at Mother Nature. Mother Nature uses fusion to light up the heavens. So now explain to us how Mother Nature uses the process of fusion, not fission, to light up the universe.
Yes, it's fusion is responsible for all life on Earth. The sun is essentially a big ball of hydrogen. It's hydrogen gas, and when it was coalescing, it was compressing itself under its own gravity. And collapsing, compressing objects get hot in general. And so you've got this ball of hydrogen that got hot and dense, hotter and denser. And eventually it got so hot and so dense that the hydrogen, moving extremely fast because of the energy of the temperature, the high temperatures involved, started slamming into each other with enough force to cause fusion reactions. So once you get a big ball of gas large enough to collapse under its own gravity and heat everything up high enough, you get a fusion reaction. And the fusion reaction is what makes the sun shine. These hydrogens getting converted eventually into helium release energy, and that energy shines out in all directions. That's what makes stars shine. But this reaction is extraordinarily difficult to get going. You need such an enormous ball of hydrogen to kickstart that fusion reaction that it's hard to do. Even a mass of hydrogen the size of Jupiter is almost like a star. The problem is it's not large enough to get so hot that you start that fusion reaction in its belly. So Jupiter is, in essence, everything that a star has except just that extra gravitational oomph to get it hot enough and tight enough to ignite.
And in fact, in the movie 2010, Arthur C. Clarke talks about aliens igniting Jupiter, so our solar system becomes a double star system. However, Jupiter would have to be about 10 times bigger at minimum in order to get ignition. Now, let's talk about the promise of fusion. Why has fusion hypnotized whole generations of inventors and quacks and top physicists? What is the promise of fusion? Why is there so much interest in it? Why have so many charlatans jumped into the game?
Imagine if you had a sun on your desktop, that in a little bottle you had a fusion reaction going. If you could get this, if you could have something like this, you basically have an unlimited source of energy. Hydrogen is abundant. It's the most abundant element in the universe. It's everywhere. It's in the oceans. Water is 2 atoms of hydrogen for 1 atom of oxygen. So if you were able to tap into the sun's reaction and turn hydrogen into helium and releasing energy in the process, you can turn this virtually unlimited source of fuel into energy for free. And because the fusion reaction, if you manage to get it working in the right way, you could just keep feeding hydrogen in, and helium and energy come out. And helium is clean. I mean, if you wanted to, you could release it into the atmosphere and it would float up into space. And so this promises, in theory, unlimited energy with unlimited fuel and no waste. Reality is not quite as simple as that, but that is the promise.
Okay, and for Spider-Man fans, for those people who saw Spider-Man 2, Dr. Octopus creates fusion in his laboratory in Manhattan, which is not the place to do it. But the machine looks like a little sun. It looks like actually a star. And you can see sunspots and solar flares on this miniature sun. However, in real life, we don't expect to create a miniature sun like in Spider-Man 2. What will a fusion reactor really look like?
Well, there's two main areas that mainstream fusion researchers are looking at to make a real fusion reactor, and they are lasers and magnets. Lasers are a very clever way of getting the heat and pressure that you need to take a hydrogen pellet and make it collapse and start fusing. Basically, you shine laser light from all directions, and you squash a tiny pellet, and as it squashes, it compresses, and hopefully it ignites. And if you manage to get lasers that are strong and efficient enough that you create more energy out of that collapsing, fusing tiny pellet of hydrogen than you consume by getting the lasers going in the first place, then you've got a source of energy. You've got a fusion reactor. No one has gotten that far, but it is theoretically possible. Another method is using magnets. It turns out that magnetic fields affect fusing plasmas like hydrogen. And if you shape a magnetic field right, you can create a bottle with which to contain a very hot cloud of hydrogen. And so a magnetic donut shaped right and with a cloud of hydrogen you throw heat in, eventually you might get a fusing plasma. And once you get that reaction going, you just have to figure out a way of piping new hydrogen in and piping fused helium out, and you've got a source of energy going. Again, these magnetic bottles aren't working to the point where you get more energy out than you put in heating the plasma and containing it. But in theory, if our magnets improve and our knowledge improves over time, you might have a magnetic bottle that contains a miniature sun.
Okay, now, because a fusion machine would use ordinary seawater, which is limitless pretty much, as the basic energy source, and because the energy released is almost limitless, the number of charlatans and quacks that have gone into the business is quite large. So let's talk about some of the false starts and some of the dashed hopes, beginning with Dr. Richter, but the list is long. Let's talk about some of the false starts.
Yes, the goal is so lofty, that the unlimited energy, that the idea of fusion has attracted quacks and hoaxers and genuine scientists who are misguided from the very beginning. In 1951, the world was absolutely stunned to headlines that Argentina, of all places, had solved our energy problems forever. There was a German expat named Ronald Richter who had convinced Juan Perón to fund a research laboratory on a secret island in the middle of a lake to get fusion reactions going in what he called a solar thermotron. And he kept the world going for about a year. People were arguing back and forth. Could he have done it? Could he not have done it? It turns out Richter was barking mad. He would get this wild look in his eyes and dump a whole bunch of gunpowder into his experiment and blow the doors off of his laboratory in gigantic explosions and rush out and write fusion on a piece of ticker tape. And yet, for many months, he kept Juan Perón's government believing that he was on his way to solving the world's energy crises, and this would be a great prestige for Argentina. Eventually, physicists in Argentina convinced Perón that something was going on that was a little fishy. They went and visited the laboratory with their own Geiger counters, and if in fact you have fusion reactions going, you should be able to detect neutron radiation coming off, and they detected nothing. So they proved that Ronald Richter was perpetrating a fraud, and contemporary accounts say that he wasted between $4 million and $70 million of the Argentinian treasury in the process of pursuing his dream. And he disappeared off the world stage very rapidly, as you can imagine. But, in fact, everyone who is involved in fusion in some form winds up deceiving themselves or deceiving others about their achievements. In 1958, British scientists at a very, very prestigious lab built this machine called Zeta. Zeta was a magnetic bottle of sorts, and the scientists had convinced themselves that they had gotten fusion in a laboratory. And they cracked open beers. They announced to the world that they were on their way to solving the world's energy crises. Turns out that they were wrong, that they were not seeing fusion, that they were deceiving themselves with neutrons. They were seeing neutrons, but it wasn't from fusion that they wanted. So they had to humiliate themselves on the world stage. After all these tabloids said energy to last a lifetime, no more energy bills, the British teams had to say, well, not really.
Okay, now more recently, we had this huge fiasco concerning two chemists, Pons and Fleischmann, who grabbed world attention, covers of, I think, Newsweek magazine and the New York Times, and everyone was talking about, well, did Pons and Fleischmann create fusion in a bottle? Not hot fusion, the hot fusion of lasers and magnets, but cold fusion. So tell us a little bit about cold fusion.
Yes. In 1989, two chemists, one of whom was extremely well celebrated, made this announcement to the press that absolutely stunned the world. They claimed that where these hot fusion, this magnetic fusion, this laser fusion research has been failing for years, wasting tens of billions of dollars, these two chemists, working independently, had spent $100,000, and they had solved the problem. And what they argued was that they managed to pipe hydrogen into a chunk of metal, of palladium, which has the interesting property that soaks up hydrogen like a sponge. And the theory was that if you get enough hydrogen in there, the hydrogen will be forced so close together that they might be forced to fuse. And in doing the research on their own, they thought they saw more energy coming out of their palladium cell than was going in. So they thought they had created a device which was creating fusion energy. So as you can imagine, as soon as this was announced, it was headlines everywhere. Cover of Time, cover of Newsweek, New York Times, Wall Street Journal, everywhere was talking about this for months and months and months. It turned out that the scientists were deceiving themselves. There was a bit of fishiness. Some data was moving back and forth. It's uncertain exactly what was going on, but when the cells were reproduced in better circumstances with more sophisticated equipment, it turned out that there was no excess energy, and more importantly, there were no neutrons coming out. Turns out when you fuse heavy forms of hydrogen together, you expect neutrons to fly away, and neutrons are a sign of fusion. They were seeing no neutrons, and that made it pretty clear that nothing was actually happening. However, it took it was a huge battle for years. Physicists versus chemists became a red state versus blue state thing, where the liberal elite physicists on the East Coast were trying to tear down research from chemists at the University of Utah. So it became a huge political battle that still affects the physics community on some level.
Now, you can simply calculate, using the back of an envelope, the neutron count that would occur if they really had fusion in a bottle, and it's sufficient to kill them. So the very fact that Pons and Fleischmann are still alive means that they could not possibly have attained fusion in a bottle. But then the question is, well, what did they attain? They did get net energy coming out. That's been verified by different laboratories. Some people have gone back to the literature on palladium. Back in the 1800s, it turns out that a person applied for a patent for one of the first cigarette lighters. He used palladium, put it in water, and attained a net amount of energy, which he used to light a flame, and he got a patent for it, a palladium cigarette lighter. And some people think that that's what they discovered. Well, what are your thoughts? It's been several years since then. What did Pons and Fleischmann really have in their bottle that gave energy? Was it a cigarette lighter or what?
It's really hard to tell. Palladium has an extraordinarily interesting chemistry. It has been fooling researchers for years, as you've noted, that and not only is there that patent, a number in the early 20th century, two researchers thought they had achieved fusion in palladium. And because they were thinking along the same lines as Pons and Fleischmann were, and they thought they detected helium inside, an excess of helium inside palladium, which would be a nice sign of fusion because you're creating helium. It turns out that they were deceiving themselves because it turns out palladium soaks up helium just as well as it soaks up hydrogen, so you have enriched helium. So if they were seeing excess energy, and it's not entirely clear from the setup of the experiment that they were, I mean, they certainly thought they were. There was some sloppiness. But it's certainly possible that they were seeing it. It would most likely be a matter of chemistry, a chemical reaction where bonds are breaking, rather than a nuclear reaction where bonds in the center of a nucleus are being formed, that the nuclear bonds that change atoms into other atoms are what are changed in a fusion reaction, as opposed to the attachments between atoms, which are chemical bonds, which are being changed in a chemical reaction like burning paper or cracking water. And so whatever they were seeing almost certainly was a chemical reaction. And chemical reactions are well studied, and there's only so much you can do for solving the world's energy problems with chemical reactions. In fact, burning gasoline is an extraordinarily efficient chemical reaction that allows us to power our cars. So it's not certain that there's anything there for solving the world's energy problems unless you have a nuclear reaction of some sort. And it's pretty clear that that is not what they saw.
Now, to a physicist, it was absolutely staggering that you had these two respected chemists that didn't understand anything about the quantum theory. If you bring the protons together very closely, as you mentioned, then you could attain fusion. But you have to bring them really close, 10 to the minus 13 centimeters. However, in the Pons and Fleischmann experiment, these atoms were separated by 10 to the minus 8 centimeters, and you can simply, using a back-of-an-envelope calculation, this is what we give our undergraduates. Our undergraduates can calculate that the fusion you get in a bottle is almost zero as a consequence. So for the physics community, what was absolutely staggering is the fact that chemists don't know any physics at all. Well, let's move on, because we had a story, another apparently fraudulent story that just took place a few months ago, this time at Oak Ridge National Laboratory, involving something called bubble fusion. So explain to us what is bubble fusion, and how did the Nazis, of all people, first stumble onto this whole thing called sonoluminescence?
Yes, sonoluminescence is this really bizarre reaction, and it's only very recently been understood, where basically you take sound waves and you bombard a liquid with it, and you induce what's called cavitation. Under the right circumstances, if you hit water very hard, it actually behaves like a solid, and it can crack, and just for a tiny fraction of a second, you can cause a crack in water. And what happens when you have that crack is you create a little vacuum, and that vacuum causes water to evaporate, and it causes a bubble. By bombarding liquids with sound waves, you cause these bubbles, and if you time those sound waves just right, you can cause those bubbles to collapse very dramatically. And it was discovered that if you do this just right, you get such a dramatic collapse that you get some sort of reaction. No one quite knows exactly what it is, even today, that causes a little flash of blue light. So if you turn off the lights and you bombard a tub of water with sound, you can actually get tiny little lights. And it's poorly understood, but it's really cool. You've got a mechanism for compressing and heating something, and a gentleman out at Oak Ridge named Russi Taleyarkhan came up with a clever idea of how to get enormous bubbles by shooting neutrons into the liquid that would collapse dramatically. And his hope was that by having this dramatic collapse and heating and compression, you might actually induce fusion in the center of the bubble.
Well, I'm afraid that's it for exploration. Once again, this is Dr. Michio Kaku, Professor of Theoretical Physics at the City College and the Graduate Center of the City University of New York. And this has been the second half of Exploration.